Hello Internet. Today we have this cute, but very evil EVGA 3060 Ti that came in for repair after falling on the floor. On top of that, the owner said that the GPU has Hynix X005 on board, which means that it will most likely need to be replaced, but we'll get to that later. Once disassembled, I begin my journey with measurements, looking for any short circuits in most common places, such as 12 volt, 5 volt, 3.3, 1.8, memory, and PEX. Everything looks okay. I'll power the card and see what it does. And it looks like it doesn't do much, because we're missing 1.8 volt, which is generated by this GS9216. Datasheet for this chip does not exist, but it's a close match to AOZ2261NQ, so let's take a look over there. With the pinout memorized in our mostly filled up brains by YouTube content, we're going to test the pins in their order, starting with the voltage in. 12 volt there, that's good. Continuing to the enable pin. 0 volt on the enable pin. That's not good. The enable pin also reads 83 kilo ohms, so it's not short, which means we need to start tracing it and see where it goes. Just by following the board itself, we see that the trace goes to this resistor, which has no voltage before or after. Then, this trace goes into the depths of the PCB, so we're going to need some kind of a board view to trace its origin. This board view here will do, and if I follow that resistor, it seems to be connecting all the way to the back of the board towards the rear end of this GPU, landing on this diode here. According to the board view, this diode should be connected to the output of this logical AND gate. So if this AND gate works, we should have some output, and if the diode works, we should have the enable signal. So let's check the AND gate first. 3.3 volt on the input 1, and nothing on the input 2. Without input 2, VCC becomes a suspect since they are indirectly connected to one another. And the VCC pin measures less than half a volt for some reasons, and if I measure it for resistance in relationship to the ground, it reads 2 ohms, which means we have a short on VCC pin. This pin is powered by 3.3 volt, which also powers a number of circuits on the board. Easiest method of finding the origin of the problem would be to inject the voltage into this pin and see what starts to glow. It looks like the heat comes from the opposite side of the board, where the power monitoring IC is located. So let's remove this IC and see if that helps. Questionable component removed. Resistance on the 3.3 volt is now several kilo ohms, so let's power it on and see what it does. "5 volt present, 1.8 volt present, core present, memory and PEX, and with that there, I will solder another chip before boarding up the card. This chip is responsible for monitoring the power consumption of the GPU. If it's not installed, GPU will get stuck at low performance and the customer will not be happy. So let's make the customer happy by replacing this chip. Chip is replaced, resistors are okay, and all voltages still present. However, we still have Hynix X005 on board, which means we could still have problems. The issue with this specific memory model is that it can show signs of a dead core, while the core is not dead at all. One way to find out is to boot into Windows and run a series of stress tests before making any conclusions. So let's do that real quick and see the result. At first, everything seemed great. Dali, FunMark, some random games seemed to work, and I was about to ship the card back to its customer, but he wanted to replace Hynix memory just in case, and I couldn't say no. So let's replace the memory and hopefully nothing goes wrong. Okay, memory is replaced, resistances are good, voltages are good, let's power it on. The image we see now is coming out of the motherboard because I wanted to see if the straps need any configuration change, and according to the report, it's already set to micron somehow. Not sure how that's even possible, but it does seem to be identified correctly, so let's see if the card produces an image by itself. And there we have it, some lines on the screen. I'll run the memory test to see if there are any errors, and as you can already see, test is not looking very healthy, and we got a fail in the end. Report complains about these two chips. Maybe I had a bad batch of chips, I don't know. It can happen sometimes, so let's replace these chips and see if that helps. Chips replaced, resistances are normal, power up, and we see the exact same lines, and the memory test is exactly the same. But why? Why? There must be something wrong with the straps configurations. Otherwise, it doesn't just go from Hynix to Micron simply by changing memory chips. No. And as I was looking around, I found this resistor standing straight up and giving me a middle finger. How did it happen? I don't know. I'll take a guess of its original location, solder back down, and hopefully this will produce a positive result. Nope. Same lines, same problems, and the strap's configuration still says micron. I think this resistor accidentally moved down, since its original position, according to my diagram, should be up here, in order for it to be configured for Hynix. So I'll solder it back up where it belongs and see if anything changes. Okay, picture is now clean, no lines, strap's configuration reported correctly as Hynix. But remember, we switched to micron, so we need to properly orient these resistors in order for it to function correctly. To do that, I will be using my cheat sheet, according to which all I have to do is to move this strap, number 2, to low, and that should be it. Moment of truth, the image is clean, log shows correct configuration, and Matt's test is clean and it passes. Great job, everyone. It is time to assemble the card and run more tests. But before I do that, I decided to do a small favor for the customer and put some thermal pads on the driver MOSFETs that drive the memory phase, which were not put there at the factory for every 3060 Ti I've seen so far. Totally by accident. In any case, everything seemed to work, and I was able to play a game for a bit to celebrate the victory. And suddenly I got kicked back to desktop, and so I decided to run more stress tests. And before the test was over, I got a crash. And then I ran FarmWork with the fan speed on low to see if it crashes more frequent when the core is hot. And it was. This gives me hope that the reball might fix the issue, so let's reball. Okay, reball is complete, resistance is good, All power rails work. Let's put everything back together and confirm whatever it is that we have to confirm at this point. Everything seemed to work at first. I manually increased the temperatures, and black screen. Running a memory test while the board is still hot. Nothing wrong, which means countless hours of work did not pay off. Oh well, sucks to be me, I guess. Maybe next time. Until then, let me know what you guys think about this not so successful repair. Is it good or bad? Goodbye.